one common use case we ended up happening was like when you start to talk about distributed systems, there's a lot of fidelity in the model, right? You've got the primary network, you've got the secondary network going down to individual loads, but that fidelity is not always required, right? One of the use cases we recently had was within the all hazards demo. There is this hurricane that happens, and what they really after was like they wanted to be able to use existing tile line switches to reconfigure the network, right? Tile line switches are typically going to be on three-phase lines that are rated at 600 amperes or above. Means you don't require representation of single-phase lines on the primary, and then you don't completely require representation of the secondary, right? So if you have a model that has complete fidelity, how do you reduce to a three-phase or a primary network representation only? Because these are very common use cases within the optimization, right, where you want to reduce the model as much as possible while making sure that you don't lose a lot of information essentially, right? So we do support all of these features as well. So in this case, we have a module called model reduction, and there we have representation of different types of model reduction that you can have. In this case, the example I'm showing here is this reduced to three-phase system. All you need to do is pass the distribution system itself, the new name of the reduced model that you want to create, and then you can define if you want to aggregate time series profiles as well. In this case, I set it to false. But if I do this in the original model, if you see, I had a total of, where is the total number? The total number of components was 13,000, more than 13,000 here, right? If I call three-phase reduction here, you'll see I was able to reduce it to 1900, about 1900. So there is a significant reduction in the size of the system itself, which means the optimization problem that we're building out from this is going to be much more, it's going to be much faster, right, to run those models essentially. So the support we have for model reduction is quite comprehensive. So so you're able to build your own reduction algorithms as well. So we have, the way we structured it is, so the current implementation provides you two implementations for reduction, but users are able to implement their own algorithms as well. The second representation I showed you was just reduce model to primary network, and it just removes all the secondaries and aggregates to the primary network itself. So it removes all the distribution transformers. It's going to aggregate the loads, the capacitors, the generators, everything that you have, and it's going to lump them and add them to the primary nodes themselves, right? Again, if you see, in this case, there is significant reduction from 13,000, but it's lesser than this three-phase, right, which is expected. Again, what we also support is time series aggregation, which I think is really nice. So, for example, if your load had time series profiles, how do you aggregate that? So, for example, for loads, it's easy, right? All you need to do is just add the consumption and represent that. But for PV systems, it's difficult, right? Because you have irradiance profiles. How do you map that? So we've got some logic that kind of allows us to aggregate all of that information and represent that at an aggregate level. So in this case, for example, we set aggregate time series is equals to true, and then we can set what type of time series do you want to aggregate. At the beginning, I showed that we support two different types of time series profiles, right? A single distribution system can only have one of these. So you can either have a set of single time series in your system or a set of like the discontinuous representation that we had, but you cannot have both of them. There is going to be an exception that is going to be thrown if you try to add like two different types of time series. So depending on the type of time series you have, you can pass the class instance here, and then we'll have the reduced model is returned from that essentially. Does that make sense?